right, let's take a look at these questions we have. Why is slope-intercept form preferred method of writing equations? Why do we always want it in slope-intercept form? And that's the form y equals like 3x plus 7. Why do we like that? Well, because it's so easy to graph it when it's in that manner. It's so easy to graph. That's why we always prefer things, for the most part, in slope-intercept form. For example, let's say we want to graph y equals 2x minus 1. Well, right away, I know the y-intercept is at -1 and the slope's 2. So I'll go up 2 over 1, up 2 over 1. And it's positive slope. That's why I went to the right. Connect my dots and boom, I got a graph of the thing right away. That is why slope-intercept form is the preferred method in most situations. So think about it. What's easier to graph? Y equals 2x minus 1 like we just did? Or what if I said, hey, -2x plus y equals 1, graph that? Well, you'd have to probably make a T-chart and figure things out, or you could rearrange it to get it in slope-intercept form, which is what we want to do. So let's take a look. Let's say we want to change this equation, x minus y equals 5. Now, the form it's in right now is called standard form, and we want to rewrite it so that it's in slope-intercept. Well, to do that, we want to rewrite it so that it's y equals something x plus the number. So in other words, get y by itself. Here there's a couple options, but let's go ahead and do it this way. Let's subtract the x and move it over, which is what I'll do every time, to be honest. So I get the opposite of y equals, now you want the x first. So I'm going to put the negative x first, which is -1 really. And the 5 is a positive value, so it's plus 5. Now that looks great, but it says the opposite of y. So what we technically are really coming in here and doing is we want to get rid of that by multiplying by -1. And really what we're doing is we're multiplying every single thing by -1. So -1 times that negative y gives me positive y. -1 times the opposite of x is positive x. -1 times that positive 5 is -5. Now, you could have just gone through and changed and made him the opposite of what he was and 5 the opposite of what he was. Excuse me. But it doesn't matter. So either way, y is equal to x minus 5. There, we have it in standard form. We could graph it easily. What do we have this? Well, again, move the x over. So we're going to subtract x because we're trying to get y by itself. 3y equals, and again, we want the x first, then the number. So now we're like, hey, I've got to end up getting not 3 y's, but a single y. So I'm going to divide by 3. But if you divide the left by 3, everybody over here needs to be divided by 3. Now, a better way maybe to do it in this situation, everybody had to be divided by 3. Well, it's the same as dividing each piece by 3. Because if you're dividing both the opposite of x and the plus 12 by 3, it's the same as dividing them each by 3. And that's the way we'll do it. So we get a single y here equals, well, that's -1/3 x, because really there's a 1 there. So we could write it as -1/3 x. We know we go up 1 over 3, up 1 over 3. And we would be going to the left. Plus 4 would be our y-intercept. If we wanted to graph it, don't have to. All we're trying to do here is get it in slope-intercept form, and we just did. Okay, what about this guy? Well, let's just simply move our x over. Notice we're sort of doing the same thing every time. It's like working a Rubik's Cube. Just work a certain pattern, certain algorithm, and you get your answer out. So here, what am I going to divide by? Divide by -2. Since I divided that by -2, I want to divide each of these pieces by -2. That whole side has to be divided by -2. I get y equals negative divided by negative is positive 2x. And a positive 10 divided by -2 is -5. Came out nice and pretty. And notice this equation and this equation are exactly the same thing. There's no difference between them. They just look a bit different. They look completely different, but they are the exact same equation. Now, here's a little tricky one. Okay, so again, I'm going to move my x over. I get 1/4 times y equals, again, I put my x first. The 2 is a positive. How am I going to get rid of a 4th? Well, I'd multiply by its reciprocal, which is 4 over 1 or just 4, which means I need to multiply this whole side, every piece, by 4. The left side got multiplied by 4, so the right side has to get multiplied by 4. That leaves me a y equals negative 12x plus 8. All right, we have one more here. This is the most tricky of all of them. Okay, we're going to have to learn a little something we haven't learned. We're going to subtract 1/4 x from both sides. So far we've done these exactly the same every time. Gives me negative 1/4 x, the 9 is positive. I must get rid of the 3. I have to divide by 3 is what I have to do. Okay, I'm going to have to divide by 3. The other option, dividing by 3, is the exact same as multiplying by a third. So I'm just going to go ahead and divide by 3 each of the pieces. Here, dividing by 3, the negative 1/4 divided by 3. Well, as I said, dividing by 3 is the same as multiplying by 1/3. And that gives us negative 1/12. So this is negative 1/12 x plus 9 divided by 3 is 3. Now, what you learned, if you remember, we're dividing by what? 3, which is 3 over 1. You were taught that when you divide fractions, you simply multiply by the reciprocal of the bottom. Because what you're really coming in here and doing is you're multiplying by a third here and a third here, and this all goes away to become 1. And you get negative 1/12. Now, that's a little tricky, and I know it's probably new or refreshed your memory from a long time ago. But the key is we're changing things to slope-intercept form because it's easier to graph, and it's the preferred form that most people want the equation in.